Here we go, section 11.4. We're going to do some more area, but we're going to do area with a different figure. We've done them with a, parallelogram, triangle, trapezoid, kite, and what was the last one? Rhombus, okay? So, a rhombus, let's see, now, none of them, let's see, yeah, none of them really were regular polygons, were they? I guess you could do the area of a rectangle, and if the rectangle is a square, right, it's still base times height. But let's do a regular polygon. So I just happen to have a regular polygon sitting right here. So let's make this a little bigger so we can work with it. And what we're going to do is we want to find the area of something crazy looking like this. Let me ungroup this. Why do I have... We'll fill this with white. There we go. Right? This is at the center of my polygon. So for instance, they go through this at the beginning of the chapter, and I don't know if I want to even try this. Oh my word, look at that. Let's fill that with nothing. Right? And watch, if I did this, if I made a circle, we would say if it touches, the points to this polygon, it would be a circumscribed circle. So the circle is circumscribed. Make it just a little bit smaller. Somebody's already out, aren't they? No. Oh, she went to the nurse. I guess if you can't wait, it's an absolute emergency. All right, so there we go. Watch this. So where do you think this dot is right here? It's where to the circle? It's the center of the circle, okay? And this polygon right here is not just an ordinary polygon, it's a regular polygon, which means all the angles are equal and all the sides are equal. Remember doing a chapter on that stuff? Yes? No? Okay. So we say the circle is circumscribed about the polygon, or you could say the polygon is inscribed in the circle. Anyway, either way, the only reason I put the circle here is just to see that this would be the radius of the circle, wouldn't it? From that center point to any of these vertices. Would you agree with that? So look, if I went from here to here, that's the radius of the circle, but it's also, how would you say it? Let's see what word they use. Yeah, they do call it a radius of a regular polygon. Okay, you ever think about that? That a polygon actually has a radius as well? But not every polygon, but if a regular polygon, that would be considered the radius. So if I go from the center of the polygon to a vertex, that would be a radius of the polygon. Does that make sense? All right, we had a radius of a circle, and that's all the reason that I had the circle there. So let's get rid of that circle. And I'll tell you what, let's get rid of this radius. And let's put another radius in here. Let's go, oops. Let's go from here to here. So I have two radii, don't I? So it goes from where? From the center of the regular polygon, and it goes to a vertex. The distance would be the same to every single one of these vertices.
If I could please ask you to dismiss the middle school boys lacrosse at this time. Also, Matt Kazalka, if you could come to the office. Thanks.
Okay, so I've got the radius. Now, I haven't even talked about what the equation is for this, but let's talk about this one thing. This is the one thing that's different that you've not used before, I don't think. They go from here, watch. What if I go perpendicular? Okay, yep, and they call this thing an apothem. That's weird, isn't it? It is a weird word. Okay, so where is it? It's from the center of the regular polygon perpendicular to one of the sides. Okay, it could be anywhere. I could have drawn it from here to here. As long as it's perpendicular, guess what's true about both of those red lines right there? They would be congruent to each other. Okay, does that make sense? So that would be an apothem. I could have drawn it anywhere. It's just kind of easier just to drop it straight down, don't you think? Is that apothem the same as the radius of the regular polygon? Uh-huh. Did you think before you said that? Look, it's the red one, the same as this. No, it's not. It's not the same exact thing as that. Okay, this goes perpendicular. This length right here is quite a bit longer than the red one. Wouldn't you agree? Because if I took this and I moved it down, in fact, I can actually do that here. Watch, if I did this. Oops. Yeah, just like that. Let's try this again. Did I hit it? Yeah, I think I got it. Yep, see, look at that. See, it is longer, isn't it? All right, so it's not the same distance. Um, so, let's see. Let's do the formula. Might as well. So what is the area of a regular, okay, remember this is a regular polygon. It's very important. This only works with a regular polygon. They go through some explanation of how they get to this, and we're kind of running a little short on time anyway, so I'm just going to go right to the actual formula, okay? It's 1/2, and you could do this. You could break this whole thing up into these triangles, okay? And say, you know, you've got so many of these triangles, find the area of the triangle, then figure out the area of all the other triangles. Are you with me on this? I'm not going to give you all the specifics, but I mean, I could sit here and do this. Find the area of one of these triangles, and there's how many triangles would there be if I connected them all? There'd be 6 of them, and then you could come up with this formula, all right? But eventually what you would come up with is this thing right here. The area is 1/2 the perimeter times the apothem. Yes. Okay, so it's 1/2 the perimeter. The perimeter of what? The regular polygon. So what do you need to know in order to know the perimeter? At least what? One of these sides, right? One of the bases of the triangle, exactly. Okay. Well, it depends on what they give you. Okay. It all depends on what they give you. If they just gave you the apothem and the base, then it would be a piece of cake, wouldn't it? Well, that's right. That's what we're gonna do. That's what we're gonna do. We'll get there. Okay, I'm just trying to explain what all this stuff is right now. All right, so if I wanted to find the perimeter, if I knew just one of these sides, and I knew this was what, 6-sided figure, right? It's a hexagon. It's a regular hexagon. I would just take this side multiplied by 6 to get the perimeter, correct? And then you'd figure out what the length of that red line is right there, and then you'd multiply it, take half of it, and you got the area of the whole entire thing. See where the 1/2 comes in? Because this is a triangle, it would be the area of that triangle, wouldn't it? Right? And so really, yeah. So there you go. And how do you find the area of triangles? I'm kind of telling you how to get to this, but anyway, it's 1/2 the base times the height, correct? So that would be one triangle, but you do the perimeter because you're doing how many? You're doing all 6 of them. Does that make sense? All right, so let's do that. Let's do the first example that they give us, and they say the base is 3. So we'll stick with this triangle right here, or this it's not a whole triangle, but it's a hexagon. All right, so let's say that thing is 3, they'd say. All right, so that base right there is 3, and that's all they tell you, isn't it? It's the only thing they tell you, and they want to find the area of this whole entire regular polygon. He's like, what in the world? How am I going to do that when they only give me one side? Are they crazy? Not really, because we know something about some angles in here. Look, we have a right triangle, obviously, don't we? Do you agree? All right, so it would be nice if we knew some angles in here, wouldn't it? Well, let's take a look at this. Again, how many little these triangles right here have we broken this whole thing into? There's 6 of them, aren't there? So let's find this big angle right there. How would I find that angle? Over 6. In this case, yeah, let's just stick with the numbers here, right? Because look, actually, let me just change colors. Right? If you did this, and you did this, we'll do one more. You did that. Right, so the whole thing is 360, isn't it? So if you go all the way around, that'd be 360. There's 6 of them, right? So what'd you do? You went 360 divided by 6, which is what? 60 degrees. So this whole big angle right there is 60 degrees. Now look, this is perpendicular, isn't it? And these are equal to each other, so it's an isosceles triangle. We learned this a while back, that if you draw a perpendicular line, right, to the base of an isosceles triangle, what's it do to this angle right here? It bisects it, splits them in half. So if the whole thing is 60, then what's this little angle right there? That's 30. So if this is 30 and if this is 90, then this has to be what? 60. Now it also bisects the angle, but it also does what to this base of the triangle? It bisects the base of the triangle as well, doesn't it? Remember, this goes back a long ways when we were doing this stuff a long time ago. But we've used it a few times since then. So if this whole thing is 3, what's this little bit right here?
1.
From here to here, it's just 1.5, right? We'll use 1.5. See, that's a lot of information that we could figure out on our own, just telling us that this is a regular polygon and this is 3. And then you could use trig functions, but it is a 30, 60, 90. So you could remember, what is a 30, 60, 90? It's all about the short leg, right? And what are we looking for? Do we really even care what the radius of this thing is? No. What do we care about? The apothem. The apothem, right? That's the important part. Because I can figure out what the perimeter is. What's the perimeter if one of the sides is 3? Six-sided figure, it's 18, right? Okay, so 3 times 6, right? So the perimeter is easy. That's 18. So I got the perimeter. It's the apothem that I really want to look for, and it's this red line right here. It's 30, 60, 90. What's true about the short side and the red one? The red one would be the long side, wouldn't it? The long leg. So what's the relationship between the short side? Is it twice? The hypotenuse is. The hypotenuse is, so the radius of this would be 6, wouldn't it? I'm sorry. Oh, wait a minute. What am I saying? Wait a minute. I said that this was not. Oh, yeah. So this one right here would be 3, wouldn't it? And that one happens to be 3 as well, right? Because look, 60, 60, 60, right? So that's actually an equilateral triangle. So it all is working out, right? All coming together. So yeah, that should be, this right here should be half of this here. I mean, sorry, twice as much as this right here. So that would be 3. And that absolutely makes sense because look, if that's 60, that has to be 60. Remember, that was 60 originally, right? And so what is this? 1.5 times the square root of 3, correct. Okay, 30, 60, 90. The long side is the square root of 3 times the short side. Now, did you have to know that? No. You could have used a trig function, couldn't you? All right, because look what you know. You know the adjacent. This would have been the opposite if you used the 60-degree angle right here. So you could have gone with that, couldn't you? And you would have still got the same exact answer in your calculator anyway. Does that make any sense? All right. So there's a couple ways you could have gone with this. But since it was 30, 60, 90, to me it was a little easier just saying, oh yeah, that's 1.5. That's just 1.5 square root of 3. Bang. Got the apothem. Now the rest is easy. So how do I find the area? It's 1/2. The perimeter, what did we say the perimeter was? 18, 3 times 6, times what? The apothem. And the apothem is just 1.5 square root of 3. Now, watch. I wouldn't have, put this in a calculator, get a decimal, then multiply it by this. I'd put it all in the calculator all in one shot. In fact, you can actually make it easier. What's half of 18? It's 9. So I would have just gone 9 times 1.5 times the square root of 3. And you would have gotten something like 23.4. Am I right?
Yep.
I didn't really do that in my head. I just looked in the book because they had that. And it is in meters, so we'll call it its area. So it's what? Meters squared. And that's how you do it. What do you think of that? It's not so bad, is it? So again, where did we start? They only gave us one side. The only thing they gave us was one side and said it was a regular polygon, regular hexagon, right? 6-sided figure. That's all they told us. So what did we figure out? Well, we figured out, okay, if it's regular, I can figure out what this angle is right here, right? Take 360 divided by how many triangles you would have. There's just as many triangles as there are sides on this thing, isn't there? Okay, so it's 360 divided by 6, which gives you 60. We know it splits this in half, so that's 30 and 30. That would be 60. It's a 30, 60, 90 triangle. It also splits the base or the bottom of this triangle in half, so that's 1.5. How do you find the long side, which is the apothem? You take square root of 3 times the short side, bang, right there. Plug it all in. That's the apothem. That's the perimeter. 1/2 of it. You got the area. Let's do another one of these, though, okay? That was kind of easy because it was, 30, 60, 90. All the composite things, you can figure that out yourself. Tell you what, you could probably figure out all this yourself after that one. Watch this. What if you had this? Let's just set it up. I won't do the whole thing because of time. But let's take a look. Watch, if I wanted to draw to there, to there, there. How many sides does this thing have? Okay, so watch this. What's that angle? How do we figure that angle? 360 divided by 5. Okay, which is 72 degrees. But then we got to find the apothem, don't we? What's the apothem? It's right there, okay? And whatever, I don't know what the base is, whatever. They give you some number. Actually, they give you this. They give you that length right there. All right? So what's this angle right here? It's 36 degrees. You can find this angle, do some trig,
Just a couple
okay?
reminders.
And
There's
then
a
you can
high
find
school
the
National Honor
apothem,
Society
but then you also have to
meeting
find the bottom of this,
this,
don't you?
period, 8th period.
So you work
Not
on
sure
that.
the
You can do
location,
it.
but
I've given you enough
maybe wherever you would
information.
normally
You know about
have
trig
those
functions
meetings.
and all that
I
stuff.
could also ask Travis Costello to come to the office and Josh.
All right,
Morse.
I'll do
Thank
the
you.
rest as you leave, but make sure you get the homework. You get the homework?
It's a worksheet. I got it.
Nothing. No. It's on your thing. It's 10 to 24. 10 to 24, section 11.4. 10 to 24. So I'll just sit here and talk to myself while you guys leave. And
I haven't written down that. Okay, we're good.
good.
As long as I don't wash my hands.
All right. So what's this? That's the This is awkward.
That's the whatchamacallit. That's the radius.
See, so that's the radius. There's the hypotenuse of this triangle, right? And so let's say we want to find this right here. That's the, let's see, and let's find this angle right. Actually, you could just use this angle up here, couldn't you? This 36. And so this is opposite, this is hypotenuse, so use the sine. So the sine of 36 is equal to opposite, we'll call it x, over the hypotenuse, which is 10. So x is 10 times the sine of 36. All right? And so what is that? That's 10 sine 36. It's about 5
Please
point,
excuse the
let's say
interruption.
9,
The Honor
right?
Society meeting is being held tomorrow,
Okay,
8th period, not today. So please go
Okay, so
to your regular
so that's
class and plan on
5.9,
attending the Honor
and of course
Society
that's
meeting tomorrow,
5.9, so
8th
that's
period.
10,
Thank
that's
you.
11.8, right? For one of the sides, so you take that 11.8, multiply it by 5, whatever that is. Yeah, whatever that is, and then you find the apothem. How do you find the apothem? Use the same angle right here. This is adjacent, isn't it? So you use the right. So you use the cosine. So it's the cosine of 36 equals the adjacent. We'll call that y. And let's call it a for apothem. Okay, is adjacent over hypotenuse again, and so you go a equals 10 times the cosine of 36, and then you got your apothem right there. That's your a. Yep, and so you take that and multiply it by whatever you get that, take half of it, and you got the area of the whole thing. So that's not so bad, is it? Okay. Thanks for sticking around, Michael. Yep.